Students, welcome to my channel Content Hub. Today I am going to explain about the operation of the quadratic probing. So mostly we will perform insertion, deletion, searching, printing. This type of operation we are going to perform on quadratic probing. So I will going to explain here the insertion operation. This is almost similar like the linear probing, but still I am going to explain here each and every step to insert the element using quadratic probing in my hash table. So here given that you have to insert these three elements in the hash table, and already the one table is given with some element. So 70, 82, 93 is already stored in my hash table. Now I am going to store 41, 50 and 60 using this pseudocode. So now I am going to pass 41 as a value here. So I am going to pass here 41 as a value. Now what will I do? I will calculate index of that 41. If I calculate index means value modulus table size, and my table size is 10. So 41 modulus table size 10. If you do calculate, you will get that value is h of k value is 1. H of k value is 1 means index is 1. Now this two line of code is saying that if hash table of first index equal to null, it means that is first index is empty. Is first index is empty? Yes, it's empty. Then hash table of first index equal to 41. So go and store 41 at first index. Now my next element is 50. My next element is 50. So now instead of 41, now I'll pass 50. Now I'm going to pass 50 here because I want to store the insert the 50. So I'm going to pass here 50 and then calculate the index of the 50. Then you will get that index is 0. 50 modulus 10, if you do, you will get that index value is 0. You will get index value is 0. Then check that if hash table of 0th index equal to null. Go and check that is 0th index is null. No, this is not null. Condition fail. Come to the else part. Come to the else part. Then check that I equal to 1. 1 less than table size is 10. 1 less than 10, yes, condition true. Then what will you do? Then calculate index using quadratic probing, because here collision occur. Because 0th index is filled means that collision occur. Then you come to the else part. In else part, what will you do? You calculate the index using quadratic probing, and in quadratic probing, what will you do? You got that HK value is what? 0. 0 plus I value is what? 1. So 0 plus I square, 1 square, I square is what? I value is 1, 1 square is 1. So 0 plus 1 modulus table size is 10. You will get value is what? You will get value is 1 here. Now check that is hash table of first index equal to null. Go and check that first index is equal to null. No, condition fail. Then what will you do? Increment the, now don't run this because this condition is fail. Now increment the I value. Now I become 0. Sorry, I become 2. Now my h of k value is 0. H of k value is 0. 0 plus 2 square. 0 plus 2 square, that you will get that 4. 4 modulus 10, then you will get that 4. Check that is 4th index. Here this condition, hash table of 4th index equal to null. Check that hash table of 4th index equal to null. Yes, this is empty. Then what will you do? Hash table of 4th index equal to value. And what is my value? 50. So this 50 is going to store at 4th index. 50 is going to store at 4th index and then break. Then break because you have to store the single element, then come out. Now what is my next element? Now my next element is that 60. Now I am going to store the next element is 60. For that I am going to pass here 60 and come here and calculate the index of the 60 and check that what is the index coming. So if you are going to calculate index of using the normal method, you will get again index value is 0. Now check that is 0th index is free. No, it's not free. Collision occur. Then come to the else part. Come to the else part. I value is now 1. Now h of k value is what? 0. 0 plus I square, and I square is 1 value. 1 square is 1. So 0 plus 1 modulus 10. You will get again 1. Now check that is has table of first index is null. No, 41 is already there. Again collision. Then increment the I value. I become now 2. Then h of k value is what? 0. 0 plus 2 square is 4. 4 modulus table size equal to what you get, that 4. Go to the fourth. Check that. Has table of fourth index equal to null? No, this is also collision. 50 is already there. Again collision. Increment the I value. Now I become 3. Now I become 3. Now again calculate index. 0 plus 3 square, that is 9. 9 modulus table size 9 modulus 10. If you do that, you will get the index value is what? 9. And check that. Has table of ninth index equal to null? Yes, this is null. Then what will you do? This 60 is going to store at where? On ninth index. 60 is going to store on ninth index. Right? Then similarly what happened, if all this table is completely fail, then this for loop is going to fail, and you come out and you check that is I equal to table size. Then if it is all table is completely filled, this condition will be true, and then it will going to message that element can't be inserted because your table is completely filled, because your table size is 10, means you can only store 10 element. If sometimes 12 element came, 100 element came, then how can you store the 100 element if you have the table only 10? Means in real life example, if I'll tell you that if you have only 4 chair and that 6 student came, that how is possible that 6 student is going to store? So that's not possible. So that time you just message that element cannot be inserted because table is completely full. Okay, next operation is the searching. The insertion operation that I have do, same process I will do for the searching also, right? So what I am going to do, suppose I am going to search the 50. Here I am going to search two element. One is 50, that is in my table. Another is 45, that is not in my table. So two possible case will mainly search. So I am going to do two possible case. 50 I am going to search it first. So I will going to pass here 50. I am going to pass here 50. Then what will I do? I will going to calculate the index of the 50. So if I am going to calculate the index of the 50, value modulus table size, 50 modulus 10, you will get the index value is 0. Right? Now check that has table of 0th index is having 50 value. Go and check that 0 is having 50. No, this is not having 50. Not having 50. It means that 50 is not at 0th index. Then come to the else part. Then again calculate index. HK value is 0 plus I square. Then what will you do? You calculate the index using that HK value is 0, 0, and then what will you do? I square, I value is 1, 1 square, 0 plus I square, what you are getting, that 1 modulus table size is 10. So, and then what will you do? You check that has table of first index is having 50. No, that first index is also not having 50, it's a 41. Then what will you do? Increment I value. Now I became 2. Then HK value is 0 plus 2 square, that become 4. 4 modulus 10. What will you get? 4th index. Now check that has table of 4th index equal to 50. Yes, this is there. Then you say that index element found. Now you check the 45. You check 45. Now what will you do? You instead of 50, now pass that what? 50. You now pass pass 45. So if you are going to pass here 45, what will you do here? Again calculate the index of the 45. 45, if you do calculate, you will get the 5. You will get the index is 5. Then check that has table of 5th index is having 45. No, not having. Then come to the else part. Now do the same process. 5 plus I square, I value is 1. 1 square is 1 means 6. 5 modulus 5 plus 1 6 modulus 10. If you get that, you will get that index value is, you will get index is 6. You will get index is 6. Now what will you do? Check that has table of index equal to value. Has table of index equal to value. No, there is a empty here. There is a null value is here. Empty is here. Then what will you do? This is not true. Then again check. I is incremented by I is incremented by 1. So now I become 2. Then what will you do? Check that has key plus I square is 2 square. Now it become what? 5 plus 4 9 modulus table size. What will you get? That has index of ninth index is having that key. No, it's an empty one. It's an empty one. It means that what will you say that index what will you say that this part you are not going to execute. Then again you have to increment I, and then again increment, like that you increment. At last you reach at that I equal to table size, and then you can say that element not found in the table. This is the way of searching the element in the quadratic form. My next operation is the deletion. So in deletion, what will you do? First you have to search. In deletion, first you have to perform searching, then only you can delete. So here in deletion, your two operations you are going to perform. First search the element, reach there, and then replace the deleted element with some marker value. So while the searching searching time, it will help, as well as in deletion also. So here also similar like that in linear programming, here also you have to replace with something. So in what you are going to do here in the deletion problem, first suppose I am saying that delete the 50. First of all delete the 50. So first check the calculate the index, you will get the 0 index. H of k table equal to value is 50 there at 0th index. No, not there. Come to the else part. Then what will you do? Index equal to 0 and I square. If I do I square, I value is 1. 1 square is 1. Table size. Then check that if you are going to get here value is what? 1. Has table of index 1 is equal to 50. No, this is not true. Then what will you do? Just do what we are doing here, h table of index equal to null. So here you are writing that null. At 41 you are putting that null. Okay, and what you are doing, if it is equal then you are going to put it, but here not equal to, then I is going to increment it. Now I became 2. So h value is 0. 0 plus 2 square is 4. 4 modulus table size is 10. So 4 modulus table size 10 you do, then you will get that index is 4. Now check that hash table of 4th index is equal to 50. Yes, it's equal to 50. Now replace that 50 equal to null, means just remove that 50 and instead of 50 just put that null value. And what you message that deleted from the hash table. The 50 is deleted from the hash table, that you can message. So this is the deletion operation. So these are all these operation of the quadratic problem. Thank you for watching my video.